Hello mathematicians, so we're on day 2. The graph of a quadratic function continued. We're still looking at some of the characteristics that make up a quadratic function graph. And today we're going to look at something called the two different types of quadratic equations and functions. One thing is clear, that the equation is still the same. Y equals ax squared plus bx plus c. Now we're talking about what the graph looks like, what the parabola looks like on the graph. So when a in the equation or function is positive, the parabola opens up. So I'm just going to sketch that over here. So the parabola will look something similar to this. And I'll put my arrows. And we're saying that the curve reaches a minimum value. So we're actually just talking about our turning point here. So a turning point in this case is right here. And that would give us a minimum value. Where if, in the other case, if a was negative in our equation, the parabola would open down and the curve would reach a maximum value. Oh, it's a straight line. Hold on. In this case, our parabola would be facing down. Okay. And our turning point right over here, okay, would give us a max value. And some things I like to think about, or some things that would help me remember, is when you're positive, you're always smiling. And you could see the parabola smiling. And sometimes when you're feeling down and just like in a negative funk, you usually tend to frown. Okay? And you can see the parabola here is frowning. Just some helps. So more of our vocabulary for the day, just a tad, is how do we graph the parabola? Well, one thing is that you always want to be able to find the axis of symmetry by using the formula if the equation is given to you. And then you want to make a table of the values of axis of symmetry, x value in the middle, and the y should repeat on both sides. Something that we looked at yesterday, actually. So, for instance, actually, we could just do this with the first one. Okay, there's the line that I hate that I make. Okay. So let's go ahead. It's saying consider the quadratic equation f of x equals negative x squared plus 6x minus 4. And let's go to our calculator to help us graph. And we go to the y equals screen. We'll put the negative x squared plus 6x minus 4. We could go to graph just to see what it would look like. And if you notice, that is actually a frown. Okay, and then let's go to our table. So we're thinking about our table. Straight from our table, we could actually pull out right away that turning point because all the other numbers around it repeat. So if this was our table, we had our x and y value. I'm going to go from 0, negative 4, 1, 2, 4, 3, 5, 4, 4, 5, 1, and 6, negative 4. Some things you might be noticing is, well, this is our turning point, and everything around it on our y values should be matching up. 4 and 4, 1 and 1, -4, -4. Okay, so that's what number 2 and 3 are referring to. We're saying that knowing what the turning point is and then being able to then see the patterns around it. Okay, because the numbers repeat. And that makes sense, right? Because if we were to fold our parabola in the center of the axis of symmetry, well, each side of our parabola would line up. So meaning that our y values should be matching up as well, right? So if we were to fold this here, 4 will go on top of 4, 1 will go on top of 1, -4 will go on top of -1. Okay, so I'm just actually going to clear that. And let's start graphing and plotting these points. Oh, I should have kept it up to help us graph first. So I'll keep it up so we could graph them. 0, -4, 1, 1, 2, 4, 3, 5, 4. If you notice, these are actually just lining up very nicely with each other. Okay. There's a parabola. Okay. Now remember, annotating is really important. So before we start looking at questions, let's start making some annotations. Well, I could start with my axis of symmetry. That cuts this in half. Right? And I could label this AOS, axis of symmetry. Okay. And remember we talked about the equation would be an x value. So here it'd be x equals 3. I can also label where the graph is increasing and decreasing. Remember, we read the graph from left to right. So here it's actually increasing. And then after the turning point, it's decreasing. I can circle the roots, right? It's where they were across the x-axis. And I can also pull out the turning point here. Another thing we can do that we just talked about is, can I get another color? Yeah. That here, this would give us a maximum point. Okay, so another annotation to add on. And one thing I did forget was I forgot to label the graph. I would have gotten -1 point. Okay? Alright, so now I'm going to erase this part here. And let's start looking at these questions. So all annotations should be done before starting to answer the questions. Okay, so it says label the vertex, the turning point. All right, so another word for turning point is vertex. So something we already did. Why is the vertex a maximum point? Well, we know it's a maximum point because the a value in the equation is negative, and that will cause the parabola to open downwards, which would give us a maximum point. So that would be our answer. A is negative. Which causes the parabola Okay. Letter C. What is the equation for the axis of symmetry? Something else we annotated. Okay, but it says use the formula of the axis of symmetry. So let's see if we could use the formula to get the same answer. So we have x equals negative b here is 6 divided by 2, and a is negative 1. And you get negative 6 over negative 2, and that is 3. Exactly what we have here. Now it says, what is the domain and range of the function? Some throwbacks. So remember, domain focuses on the x-axis, and we read domain from left to right. So here the domain would be from negative infinity to infinity, right? Because we don't know if this parabola is going to get wider or skinnier, okay? There's really no restrictions there. And when we're talking about range, we're talking about the y-axis. And we're looking at the y-axis, we're actually going to be reading it from the bottom to the top. So our lowest y value here, because of our arrows, you know that's going to be going on to infinity. And here, well, that's our actual maximum point. What's the highest value on our y-axis? And that is actually 5. And that is going to be a bracket because it's included. Okay, now let's go down to our last point where it says determine the zeros of the quadratic equation to the nearest tenth. Another helpful tip, I know that my answer is going to have a decimal. So let's write it again. Negative x squared plus 6s minus 4 equals 0. And then I'm going to use a quadratic formula. A, B, C. A is negative 1, B is 6, C is negative 4. I'm going to plug that into our formula. Extend this. And everything is over 2 times negative 1. And then that will give us, remember we do everything under the radical first. So under it, negative 6 plus or minus square root of 20 divided by negative 2. And if I split these up, I would have negative 6 plus radical 20 over negative 2, negative 6 minus radical 20 over 2. And here, when I put that into my calculator, I would get 0.8. If I put this into the calculator, I would end up with 5.2. Remember, round to the nearest tenth. So then I could say that x is equal to 0.8 comma 5.2. Those are 2 x values. Okay, thank you.